The colonization of Europa, one of Jupiter's moons, is a topic of great interest and speculation, both in science fiction and among scientists considering humanity's future in space. Europa is an icy moon, and its potential for colonization primarily stems from the possibility of life beneath its thick icy crust. While no human colonization has taken place yet, the concept involves numerous challenges and potential strategies for habitation. Here's a detailed breakdown of the current knowledge and possible steps towards colonization. Europa's environment. Europa has a very cold and hostile environment that presents numerous challenges for human colonization. Surface temperature. The average temperature on Europa's surface is about 160 degrees Celsius, 260 degrees Fahrenheit, far colder than any environment on Earth. Atmosphere. Europa has an extremely thin atmosphere, mainly composed of oxygen, but it is too thin to support human life. Icy surface. Europa's surface is covered in a thick shell of ice, about 15-25 kilometers, 9-16 miles, thick. This ice is thought to cover a global subsurface ocean, which could be a potential habitat for microbial life. Radiation. Europa is bathed in high levels of radiation from Jupiter's strong magnetic field, making it hazardous for human life without proper shielding. Scientific exploration and goal. Search for life. One of the primary motivations for colonizing Europa would be the search for extraterrestrial life. The subsurface ocean beneath the ice could harbor microbial life, and some researchers believe that Europa's ocean might be one of the most promising places to look for signs of life beyond Earth. Habitat development. Any colonization effort would need to focus on developing habitats capable of withstanding extreme cold and radiation, while providing life-supporting systems like breathable air, food, water, and waste management. Resource utilization. Europa's ice could potentially provide water, and extracting hydrogen and oxygen from the water ice could be vital for creating breathable air and rocket fuel. Technological challenges for colonization. The colonization of Europa would require overcoming several major technological hurdles. Radiation protection. One of the most pressing issues would be Jupiter's intense radiation. Radiation on Europa's surface is 1,000 times stronger than on Earth. Colonists would need to live underground or in heavily shielded habitats. This could involve digging beneath the ice to access more protected areas. Transport. Getting to Europa itself is a challenge. The distance from Earth to Jupiter is approximately 628 million kilometers, 390 million miles, and current space travel technology would require years to reach Europa. Technologies such as advanced propulsion systems or space tethers would be necessary to make such a journey feasible. Energy generation. Europa receives very little sunlight due to its distance from the Sun, so solar power would not be viable. Colonists would likely rely on nuclear energy or other advanced technologies to generate power. Subsurface exploration and ice drilling. The thick ice crust would need to be drilled through in order to access the subsurface ocean. New technologies for drilling through frozen environments would be crucial. Some concepts include robotic drills, nuclear-powered heaters, and ice melting techniques to penetrate the surface. Life support systems. Advanced life support systems would need to be developed to provide oxygen, water, food, and waste management. The habitat must be a closed-loop ecosystem capable of recycling resources for long-term survival. Building habitats. The colonists would need to live in pressurized, insulated, and radiation-protected habitats. Concepts include inflatable modules, subterranean habitats, or domes with thick shields of ice or other materials. Colonization scenarios. Initial missions. Before any actual colonization could occur, robotic probes would be sent to conduct in-depth studies. NASA's Europa Clipper mission, which is planned to launch in the 2020s, will provide more detailed data on Europa's surface and subsurface, helping to inform future manned missions. Establishing a presence. The first human presence on Europa would likely be in the form of a research outpost, focused on studying the Moon's environment and looking for signs of life. A small crew of astronauts might live there for extended periods, but they would likely be confined to temporary shelters, such as ice shelters or underground bases. Long-term colonization. Long-term human presence would require sustainable systems for food production, habitat construction, and energy generation. Colonists might rely on biodomes with Earth-based plants for food and oxygen. However, developing technologies to extract local resources, such as water and energy from the Moon's ocean or ice, would be essential for a permanent colony. Potential benefits of colonization and scientific discovery. Colonizing Europa would provide opportunities for groundbreaking scientific research, particularly regarding the possibility of extraterrestrial life and the study of ice-covered oceans. It could offer clues to the origins of life, not only on Europa but throughout the solar system. Astrobiology. The discovery of life, whether microbial or more complex, would have profound implications for our understanding of life in the universe. Human expansion. Establishing a permanent human presence on Europa could be seen as an important step in humanity's long-term goal of becoming a multi-planetary species. This would increase our ability to survive as a species in the face of existential risks on Earth. Space resources. Europa could serve as a stepping stone for the extraction of resources, including water, which could be used for fuel or for life support, facilitating further exploration of the outer solar system or even interstellar travel. Ethical and environmental considerations. Its planetary protection. One of the most important concerns when considering the colonization of Europa is the potential contamination of its environment. Europa's ocean may contain alien microbial life, and introducing Earth microbes could have catastrophic consequences for any native life. Strict planetary protection protocols would need to be enforced. Environmental impact. Humans would need to tread carefully to avoid causing long-term damage to Europa's environment, especially its ice crust and subsurface ocean. Colonists would need to minimize waste and carefully manage any resource extraction. Timeline and feasibility. While current technology is far from allowing colonization of Europa, advances in propulsion, life support systems, and space radiation protection might make it possible within the next 100,200 years. Realistically, it will be decades before even the first manned missions to Europa are feasible. The first major step will likely be the development of advanced robotic probes and the success of missions like Europa Clipper, which will help to further assess the viability of colonizing the Moon. Europa is one of the most promising destinations for future exploration, not only because it may harbor life but because it presents an exciting and challenging frontier for humanity's expansion beyond Earth. Colonizing Europa would require unprecedented advances in technology and a multifaceted approach to overcoming extreme environmental conditions. While humanity may be a long way from setting up a colony there, the scientific and technological groundwork is already being laid for future missions.